spring force. We are dealing with this part today. Now, if this is massless spring, in unstretched form, will there be any spring force?
No, sir.
If kept unstretched, there can't be any spring force. No spring force. But if it is elongated by delta x, then spring force will be acting opposite. So it is called minus k into delta x. Hello?
Yes, sir.
Yes, sir.
Where delta x may be elongation or contraction. So whenever we elongate a spring or compress the spring force will be directly proportional to that change and directed opposite. It is constant or variable, the spring force?
So variable, right? It will
Yes.
depend on
Delta x.
extent.
So it is variable force because it is depending upon delta x. It is variable force. And it is opposite to elongation or compression delta x. Right, this much? Spring force is always minus k times elongation or contraction. It is variable opposite to delta x. Tomorrow I have told test on which topic?
So whatever we have done till now in laws of motion.
In law of motion I told. And
Yeah.
electrons, photon, paper I have sent you.
No, sir.
So that I will send, and whatever I did law of motion, that I will take tomorrow.
Okay, sir.
Next week also daily lecture except on Sunday. So 2-3 weeks we'll have daily class so that we can cover the portion.
Okay, sir.
Because once part 1 gets over, then part 2 I can complete in 2 months.
Done, sir.
Now if this is string, what will be tension here, anywhere?
Same, no?
It will be same throughout. If string changes, then only it will be changing. Otherwise, it will remain same throughout. T,
Yes, sir.
very same. And if it is spring, then what? Here also it remains same throughout. Hai na? See, direction will get changed depending upon where you have elongated or compressed. But magnitude wise throughout it is same. So
Yes.
that means these two are equivalent. So to solve the problem, you can consider tension is like spring only. Now imagine this is spring or of spring constant K. If somebody pulls from this side x1 and somebody pulls from this side also x1, x2. Now can you tell me what is spring force developed in this? In magnitude? It is K into x1 plus x2, where x1 plus x2 is net elongation. So if two-side pulling force is applied, then this will try to compress from both the side with magnitude k into net elongation. So remember this also, if two forces are given, then spring force will be due to net elongation, not single elongation. Clear?
Yes, sir.
Yes, sir.
Right?
Done, sir.
This is one block B, another block A, same mass, both are connected by spring. This block is pushed by 1 meter, 1 meter, and this is pulled by 1 meter. K is 100 Newton per meter. Find spring force when both blocks are displaced by 1 meter each in same direction, and second in opposite direction. So in first case, in same direction, both are pushed. So what will be net elongation? Can you tell? Net elongation in first case?
सर सब्ट्रैक्ट होगा ना?
हाँ, मतलब जीरो हो जाएगा. मतलब ये पुश किया आपने 1 से, ये पुल किया 1, तो नेट विल बिकम 1 minus 1 0. करेक्ट?
Yes.
बिकॉज 1 इट इज गेटिंग 1, ये इसको कॉन्ट्रैक्ट करता है और ये इलोंगेट, तो नेट हो गया 0. नाउ व्हाट विल बी देन स्प्रिंग फोर्स? k into 0 ना.
Yes. 0.
इन सेकेंड केस क्या होएगा स्प्रिंग फोर्स?
2 हो जाएगा.
k
1
into
plus
2
1.
होएगा. हाँ, so it will become 100 into 2 equals to 200 Newton meter. Okay, both followed? Full?
Yes, sir.
sir.
Okay. Write the question and solution properly.
Done, sir.
Yes, completed. If this is string, mass m, at equilibrium, what is force acting? What are the forces acting at equilibrium? This is string, huh? So there will be
Tension and
Tension.
mg.
tension and mg. So can I say T is same as mg?
Yes.
But suppose we have a spring connected to a block, connected to the block. Is this equilibrium position when you connect the spring to the block?
No, sir.
No, it will
हाँ, yes.
elongate. नहीं, ये तो वजन लगाते elongate हो जाएगा ना ये.
हाँ.
So suppose it elongates by distance delta x. अभी equilibrium होएगा ना
हाँ.
for spring. So slowly it will elongate, and slowly spring force will get developed and balanced. So in this case, spring force is equals to K times delta x. Which is nothing but K delta x balances mg. So from this I can say at equilibrium delta x will be mg upon K. Okay.
Yes, sir.
Yes, sir.
Now delta x is mg upon K at equilibrium. So this tension, if I think as K delta x, so here also I can write T is mg. Therefore, tension equivalent to spring force K delta x equals to mg. That means T is mg. T I told think as spring force. So it is T delta x equal to mg. So you can write here also delta x will be mg by K if you treat that as tension. But tension won't be here exactly equal to restoring force will be K delta x. So K delta x is mg. Spring force I equate with T. I can write T mg. K delta x mg. Delta x mg by K. Same आया ना दोनों में?
हाँ.
Provided you match or treat that tension as spring force. So spring force is K delta x. So tension is mg. इधर से direct equate कर देंगे तो भी चलेगा. So either you follow this method or think that as string and write string is mg, T is mg, but T is nothing but restoring force which is K delta x mg. तो ये लिख लो, फिर एक दो सम में हम लोग ऐसा ट्राई करेंगे. That means when we treat that spring as string, T should be written as K delta x.
Done, sir.
चलो एक सम करते हैं इसके ऊपर. This is spring. At the end we have block of mass m. Other end 2m. This I am taking equivalent to a string, mass m, mass 2m. Because it is same connected, so throughout tension we have to mark same. This is T, this is T, here we have mg, here we have 2 mg. What will be the direction of rotation? Clock or anti?
Clockwise.
Clockwise. So therefore I can say, in first case, T minus mg equal to ma. Correct? No? Any doubt in first case?
No, sir.
In second case, 2 mg minus T is 2 times ma. Now when you add this, Tt will get cancelled. You will get mg as 3 ma. So A will become G by 3. Okay. We are interested in elongation. A is G by 3. This much any doubt?
No, sir.
No, sir.
Now from 1, T minus mg is ma. So T is mg plus ma. That means T will become mg plus mg by 3. So I can say T is 4 times mg by 3. Just copy till this, one more line is there.
Done, sir.
You all have done this?
Yes, sir.
Now I said I'm treating that spring as tension. So I will write K times delta X is 4 times mg by 3. For spring it is K delta X. So elongation will be 4 mg upon 3K in case of spring. Complete further.
Done, sir.
Next question. This is spring. And here we have weight 2 kg, 4 kg, K equals to 100 Newton per meter. Find elongation. Just copy this diagram.
Done, sir.
I'm just converting this as tension. Huh? This is spring. Here we have 2 kg weight. Here 4 kg. Now this is string, which is converted for spring. Is it same string going here?
Yes, sir.
So will the tension remain same?
Yes. वापस G by 3 आएगा.
हाँ, अभी इधर से ये नीचे होएगा T, T. इस पे कितना टेंशन रहेगा? 2T. ये समझा कॉन्सेप्ट 2T वाला?
हाँ.
Yes, sir.
So from this figure you can say this is 4G, this is 2G. So 4G minus T is 4A and T minus 2G is 2A. Again if I add, this will be 2G equal to 6A. So A will become G by 3. So T will be 2A plus 2G, that is 2G by 3 plus 2G. 3 to the 6 and 2, 8G by 3 Now spring force is equivalent to 2T. So K delta X is equivalent to 2 times 8G by 3. Therefore, I can say delta X. Okay, chalo, just copy till this.
Done, sir.
So spring force acting is 2T, which is same as 16G by 3. And elongation 16G by 3K. Okay, understood this? How we are connecting spring to same as?
Yes, sir.
Yes, sir.
अभी इसके ऊपर एक फेवरेट सम आता है, वायर इज कट, तो क्या होएगा? Spring mass M this is string mass 2M. We are interested in what is spring force and tension in the string first case. See, this spring will come under equilibrium, then only spring force will act, otherwise not. If it is at rest without elongation, no spring force. So that means it is under equilibrium. Under equilibrium means elongate होने के बाद आया है.
Yes, sir.
मतलब देखो, ये तो रेस्ट पे है, तो स्प्रिंग फोर्स कुछ नहीं है, जीरो है. बट इफ इट elongates by some distance and now this body comes to rest, then I can say there is spring force, otherwise not.
Yes, sir.
ये तो धागा है, इसको कुछ नहीं होगा, ये नहीं elongate होएगा, ये ऐसे का ऐसे ही रहेगा 2m. तो इसका वजह से 2mg is acting downward and इसका mg downward. Here tension T, here also tension is T. This, forces followed acting on the body.
Yes, sir.
Yes, sir.
Now if I see the second body, I can say T is 2mg because it is at equilibrium, neither moving up or not down. So first equation. In the spring, what I will get at equilibrium? Tension plus mg is balancing spring force in upward direction at equilibrium.
Yes, sir.
Yes, sir.
So 2mg plus mg is spring force. That means 3 mg Is spring force acting at that time?
Yes.
इतना लिखो, अभी मैं एक अलग चीज बताने वाला हूँ इसके बाद. प्लीज राइट दिस मच. अंडरस्टैंड एंड डू. ये डिफिकल्ट आया तो ये सब आएगा, स्प्रिंग एंड स्प्रिंग. So spring force will come only when that spring gets slightly elongated. Hello.
Yes, sir.
Yes, sir.
एक मिनट, वापस बना देता हूँ डायग्राम. This is spring connected to body of mass m, then 2m. At equilibrium, this will elongate. This will not elongate. So here it will be force coming. This is tension T, and weight mg. This is 2 mg. So we got 2 mg and tension are same, equation 1. Then mg downward plus tension T is balancing that force in the spring, equation 2. Therefore mg plus 2 mg is force in the spring, 3 mg is force in the spring. This much written? You all have written this one?
Yes, sir.
Now suppose at
Yes, sir.
एक
sir.
बराबर में at equilibrium string is cut. Find acceleration of both blocks just before, just after cutting the string. So we cut this by scissor. So just after cutting, what will be the acceleration in each block? Right question further.
Done, sir.
Now, as soon as we cut the string, what will be T? As soon as we cut, tension will be 0 because there is no connection between the block. There is no connection between that block and the string. So as soon as it is cut, the spring force will not become zero because it has to move up to become zero. But as soon as you cut this, this will leave. So as soon as string is cut, T will become zero.
Yes, sir. Yes, sir.
स्टार्ट कर यार बहुत दिन के बाद प्रॉब्लम हुआ है